So the purely capacitive circuit is the circuit that contains only capacitor. We can represent the relationship between the root mean square value and the peak value of an AC. The root mean square value of an AC is the effective value of the AC, or the value of the AC that is equivalent to the DC value. So the root mean square value of current is equal to peak value or the maximum value of current sine bracket angular velocity t plus pi over 2 bracket closed. So when we differentiate sine omega t plus pi over 2, we get that the root mean square value of current is equal to peak value of current divided by root 2. Also, the root mean square value of voltage is equal to the peak value of voltage sine wt omega t, which is the angular velocity. So when we differentiate the sine wt, sine omega t, we have that root mean square value is equal to peak voltage divided by root 2. Okay? And as a result, if we graphically represent current and voltage, we can see that the voltage starts from 0. The voltage is 0 when the current has moved a height of 90 degrees. So the blue color represents the current, which has moved 90 degrees before the voltage starts. Okay? And as a result, we see that the current leads voltage with 90 degrees, or that the voltage lags behind current with 90 degrees. So we can represent voltage, current, and capacitive reactance using the formula in the screen, like Ohm's law. Okay, so the capacitive reactance is the opposition to the flow of AC by the capacitor. Okay, so the capacitive reactance is 1 over omega c, which is equal to 1 over 2 pi f capacitance. And we say that the power in a purely capacitive circuit is 0. That is to say that it does not dissipate energy. We say that capacitors do not dissipate energy. They store it in form of an electric field. The average power consumed in a purely capacitive circuit is 0 because energy is alternatively stored and returned to the circuit. As a result, let's solve this question. So from there we have that our capacitive reactance is equal to 2 pi fc, and capacitive reactance is 1 over 2 pi times the frequency given to us is 500 over pi, while the capacitance is 5 times 10 raised to the power minus 6 due to the microfarad. We have the reactive capacitance as 1 over, we multiply the values, 2 times 500 times 5 is 5,000 times 10 to the power minus 6. So the capacitive reactance is 1 over, so we move the points into 3, give us 5 times 10 raised to the power, we decrease this by 3, making it to be in a normal standard form. Capacitive reactance is 1 divided by 5 to give us 0.2 times 10 raised to the power minus 3 moves up, the minus sign goes out to become only 3. Then capacitive reactance is 10 raised to the power 3 means 1000 multiplied by 0.2 to give us 200 in ohms. That is the first question. And the second question says we should calculate the current. Okay. Then we now put the formula that links it. Voltage is current times capacitive reactance. The voltage on the screen is 100, while the reactance is 200 that we got, making I the current, the source of the formula. We had that it is 100 divided by 200. Dividing, you get your current to be 0.5 in ampere.